All right, we're going to talk about radiation for just a little bit. We talk about radiation being a way that heat can be traveled by radiation is when it passes through either air or even a vacuum, because it does not require a medium to travel through it. For example, sound waves have to have something to vibrate, and if you're out outer space and you yelled at someone across on another spaceship across space where there's a vacuum, they would not hear anything because there's nothing to vibrate. They have to have something to vibrate, and if there's a vacuum where there's nothing, then it wouldn't get there. Fortunately for us, sunlight is not like that. It is what we call electromagnetic waves, or waves. Sometimes we call these radiant energy, all right, because they can travel by radiation. That's the same thing as radiation. Okay, a lot of times people hear radiation and they're thinking, "Oh, this is dangerous radiation." Well, it just depends on what kind of radiation it is. All right, electromagnetic waves, or EM waves for short, range in energy levels from radio waves, all right, to higher up would be microwaves. Okay. And next from that would be infrared, which is basically just heat, which usually we think that feels good. If we go outside, the sun feels hot. Infrared. Light, which without radiation we would not be able to see. Okay. And then UV, which is getting to the point where it can cause, some of it can cause harm to our skin and cells and possibly mutations and skin cancer. To X-rays, which are more severe. Okay, don't want to be exposed to, but X-rays are also used to treat cancer, as are some of the things of gamma rays. Okay, and so there's a wide range of them, and radiation can be harmless to us or very beneficial actually to us, many of these types of radiation. Now, some type of UV, excessive exposure to it and certain types of it. Yes, X-rays can be used for good things, but obviously if you're exposed to too much, it could do damage to your cells. Okay, in fact, it's used to kill cancer cells, which are your cells, or whoever has the cancer cells. So it's killing human cells, but you're trying to kill the bad ones before you kill too many good ones. And even some gamma rays are used for radiation treatments. Okay, and so there's a wide range of them. They do not need a medium to travel through. They can travel through anything, air, or actually a vacuum where there's nothing there. It's a good thing for us because otherwise the sunlight and the heat that comes from the sun couldn't get to us if it were not for electromagnetic radiation. Okay, and everything then, we said that radiation or heat is given off by, from hotter to colder. Basically anything that's above or greater than absolute zero then is constantly giving off radiation. Okay, so the solar radiation, which is from the sun, it tends to be higher frequencies like light and UV. The Earth is giving off radiation also, but it's lower frequencies, not light. So that's why planets are harder to view as they're farther and farther away. They don't give off as much light radiation. They tend to be more infrared. Okay, and a lot of that comes from the radioactivity inside the Earth. The radioactive reactions going on inside the Earth, basically nuclear reactions that are releasing heat slowly, and that keeps and maintains the Earth's core in a molten state. And so that some of that heat is also given off. Some of the heat given off by the Earth is radiation absorbed from the sun, and then it re-emits it back into space. So basically everything in the universe either absorbs energy, okay, and they are also emitters. They give off energy, okay. And so if you're a good absorber, or we could say a good receiver of energy, you tend to be a good emitter. If you absorb energy well, then you're going to give off energy well. If you're a poor absorber, you don't absorb very well, you also are not going to emit or give off energy very well. So we talked about things that are net absorbers or net emitters. In other words, if you absorb more than you give off, you would be a net absorber and you would warm up. A net emitter would get cooler because or if it's heat radiation at any rate, because it's emitting or giving off more than it's absorbing, okay? And so everything absorbs and emits. It's just if we're a net absorber, we will increase our energy because we're absorbing more radiation than we're emitting. If we're a net emitter, that means we emit more than we are absorbing, so we would lose energy, and generally we tend to think of that in terms of heat. We would get colder. All right. If there were no net absorbers or net emitters, if we just all stayed with the same amount of energy, nothing would happen, because energy is the power to make changes, to make things change. And if nothing ever changed, life would be boring, and basically life as we know it would not exist. Okay? And so let's think about that for a minute. All right. Anytime something is a solid and it moves to a liquid, is it going to have to gain energy, or is it going to have to lose energy to do that? Well, to get to a solid, it's going to have to move faster, so it's going to have to gain energy and have more kinetic energy in its molecules, and therefore it will gain energy to become a liquid. If a liquid wants to become a gas, it's going to have to gain energy to become a gas. All right. If a gas loses energy, becomes a net emitter, it gives off more energy than it hangs on to, it is going to become a liquid. But it's going to have to lose energy to do that. Just as a liquid is going to have to lose energy to become back to a solid. If you're in the refrigerator, for example, the water that you put in the ice trays is going to have to lose heat in order to become a solid. And that's why your Freon, as it expands and goes through your little tubes through your walls of your refrigerator, it is going to absorb heat from the water until it turns into a solid. All right, so we're always absorbing energy this way. Things have to be able to be net absorbers to move this direction, and they have to be net emitters to move in this direction. Now, real quickly, some names. If we go from a solid to a liquid, that would be melting. If we go from a liquid to a gas, that would be either evaporation or boiling. All right, we'll talk more about the difference between those later in a second, but gases would have to condense. They would lose energy or release energy, and therefore they become cooler to become a liquid. That's condensation, like when you have a glass of ice water, it cools the air next to the glass, and therefore water vapor was a gas in the air, but it becomes a liquid, and that's why you have a little water that runs down your cup. It makes a little ring and makes your mom really mad, or wife, or whoever really angry, because it leaves water rings on the furniture. Liquid going to a solid is also going to have to lose it. That would be freezing or solidification. Okay, either one would be an appropriate name for it. All right, now sometimes we can lose energy fast enough. We go straight from a gas to a solid, which would be sublimation. Dry ice, which is carbon dioxide gas that went straight to a solid, then would be an example of sublimation. Or if you go straight from a solid back to a gas. But so that's also a phase change that could occur. All right, actually, to clarify, if something goes from a solid to a gas, that is considered sublimation. But if something goes from a gas to a solid, it's called deposition, although you never hear about that very much, or hear it called that. Another word for it is to call it desublimation. But either way, if we say sublimation, we're just going to say sublimation either way. Sublimation or desublimation, solid to gas, gas to solid. I'm not going to really worry about the distinction between those two things, but just for the record, that's it.